Hello, welcome back to More Fun Fixing It. I'm going to have a look at this Spectrum today. Well, it's most of a Spectrum. This is just the motherboard, and it's also missing a few other bits. This is not one of Paul Universal Retro Boss's computers. This is one of mine. This was donated to me a while ago by, and I'm going to put his name on the screen now because I'm old and I keep forgetting names. And he donated me a lot of stuff, including some rare bits of QL and microdrive parts and all sorts of Sinclair stuff direct from one of the factories that all of this was sourced from. But this was, I think this was part of his personal collection, and there are other ones of these. I've got these two as well, and they're all marked as faulty. So we've got this one here which says intermittent keyboard +3 RAM test fails crash, and this is an issue 3B. And this one is dead, corrupt display. And this one has a 6C001E with no designator. It's an 84 ULA, Ferranti ULA, but let me show you there. It hasn't got a -6 or 7 on it. I haven't seen one like that. That I recall. This one is a -6. So they're not quite as good, but this one in here is a -7. So there are 3 faulty boards that I can play around with, but this one drew my eye. This is an issue 6A. Let's get right down and close to this. Yeah, this is an issue 6A, and it has, well, it says memory fail at 8,000 hex. So I'm assuming that H it stands for. And on this tag here, it says modulator removed, TR4 removed, which is down here, which is a ZTX 650. So we've got a memory fault, but we've also got a -7 ULA, and which is this one? This is the ZTX 8401 variant of this Glue Logic chip. So I'd quite like to see what's going on with this one. And first thing I need to do is put a transistor in TR4. I've already measured for resistance and had a little play with measuring resistance across the coil, across the voltage regulator, and across lower memory voltage rails. And I can't find anything wrong. So I want to put a transistor in there and then hook it up and see what diagnostic says. So I've got a brand new ZTX 651 here, pin compatible, so I can put it in the right way round according to the silk screen marking. There's no work that I can see has been done to the back of this board, which is a really good place to start. Now obviously we've got no modulator on this. I've got my composite mod dodging lead from Henry here, and I'm going to hold the ground against this ground plane, and I'm going to hold the signal wire against this point here and hope that we get a signal once I plug it in. But that's skipping ahead a little bit. Let's actually get the diagnostics in there and put some power in it and see what happens. Obviously going to use my Steam Card Pro. And I'll be powering it from my bench power supply with 9 volts at 800 milliamps. 9 volts, 800 milliamps. Here we go. So what do we see here? I'm looking here on these 4 LEDs here. The top one is 12 volts, the next one is 9 volts, and the next one is 5 volts, and the next one is -5 volts. We're missing 12 volts straight away. That's with TR4 installed. That's a little bit disturbing. It's current limiting as well. It is trying to run. Right, so I gave it a little bit more current. That's quite a valuable lesson there. A little bit more current, and it stopped it voltage limiting. And the circuit started up with the extra voltage. Without the extra voltage there, it wasn't getting enough voltage to actually drive the 12 volts. I'm going to turn that up a little bit more. I'm going to give it a 1 amp. Yeah, it's happier at 1 amp. It kicked off over just over 900 milliamps. And we've got sound and we've got diagnostics running. Right, now let's see if we can get a picture now. It's not the best picture. I think that says IC20, but it's really difficult to tell. Yeah, I think that says IC20. I'm actually just going to pop a pin in here so it makes it a little bit of a better connection. Just to make sure. Just a pin header to so that I can clip that lead onto it. Right, now what do we get? A lot of interference. It's not a happy it's not a happy signal. Yeah, I think it's IC20, but I can try with Retrolium Diagnostics. Let's try that. Some of this is my capture device. It's really it's got a very poor connection, so IC20. Okay, so IC20 is the third one along here on this top row. And let's pop that out and see if that is indeed faulty. Every single one of the legs is bent outwards. I do this at the factory they put the chips in the board and then bend all the legs out so that they don't fall out of the board when it's being wave soldered. It's irritating. So I'm using my soldering iron tip, which is a nice bevel tip with a flat face, just to push each one of these back towards the center of its hole. If you try and use the desoldering station to do this, it will actually just end up taking pads off. Right, heat gun on 330 degrees, maximum airflow. Not putting any pressure, just the tiniest amount, just giving it a wiggle, and it's moving now. There we go. The one piece of advice I can give to anybody that wants to learn how to remove chips cleanly without too much risk of pulling up traces, you will do it sometimes. This is another thing I'll say, is take your time. And if you feel pressured and rushed, stop. So I have a new chip tester on the way that I'm very excited about. But I'm not going to give any details about that yet. Dead. Okay. Very snaggle-toothed chip going back in here, but if it works, that's what it's going to get. It's got legs all over the place. Hey, it's a beauty. I'll clean that up as best I can. I'm not sure this is going to work. It actually looks like it's got some rust on these legs. Well, it's gone in there quite nice, so maybe it will. Okay, let's try just turning it on. And seeing what happens. That looks pretty good to me. I'm going to just power cycle that. It looks like it's got the full 48K as well, but I will test it. Okay. Oh, we're going for a Retrolium. Marvellous. That's given that a clean bill of health. I'm just going to run it through the other one just in case. Yeah, looking good. That's where I could leave this now, and I did want, well, my first intention was to find a spare modulator and just pop that in here and then leave it at that. But sadly, I don't have any spare modulators left. I've managed to run out. All my scrap boards have had their modulators pinched. So I had another idea. Some time ago, I was given this, and this is an SVHS board for the ZX Spectrum. So the reason I never used this before is that I don't really use SVHS. I got it on my capture device, and I've got it on this TV here, but I don't use it anywhere else. I just, for testing purposes, I just want to plug in composite or RGB, and there's no RGB that or modifications that I'm aware of for the ZX Spectrum, which would be marvelous. But this can just sit there, and I can just use a standard SVHS cable to connect this. So how about we do that? I'm going to have to look up the schematics or the GitHub. It's designed by Retro Adventures. ZX Spectrum S Video Modification Revision D0.1. Looks quite cool. I'm going to have to find a cable to go here. I might have to remove this header and just put in some wires instead. But it says Luma, 5 volts and chroma for those 3 pins there. That should give me S-Video. I'm going to also have to put something underneath the board, probably some sort of insulator, just to hold it up off the board, because otherwise these connections will short out on here. Or I could just put some tape across the bottom here. That would also work. And then I need to solder it to these 2 points here to hold it in place. Yeah, I think tape is the way to go. I need to remove this pin as well. Right, let's do that. Let's try it. I'll also have to try and find my S-Video cable, because I really haven't used one for such a long time. Yeah, I'm just going to put some duct tape over this area. And all of these contacts on the bottom are not sharp. I might put some across the bottom of that, actually. Yeah, let's do that. Oh, that once that's pushed down tight, that'll be good. Right, let's find. I've got these pins again. I'm going to use these, but what I'm going to do is solder these in place with these plastic parts there, and then I'm going to take the plastic parts off once they're in and straight. Probably need to do these one at a time. And these are required because that's the ground connection. Excellent. There we go. The bare naked pins. And this should just sit down on there. Marvellous, lovely big fillets of solder there to hold that in place. That's not going anywhere. Yeah, it's really good. There's a little bit of play, tiny little bit of play if I wiggle it hard, but that is that's going to be solid. I could just put dribble some adhesive down there if I wanted to make it extra solid, but it's going to be plenty just for pushing against that. So let's find a connector for this. I don't know if I've got anything for this. Oh, that's perfect. Right, so I just need to make up a cable and connect up the chroma 5 volts, and 5 volts is right here, and I can tack that off of anywhere along here. And chroma and luma. I've just noticed something. It's not an LM1889N, it's the other one. I'll leave it in place for now and we'll see what the video signal is like. But I have some new old stock LM1889Ns and I could just pop one in here if I need to. But I will try it without. Chroma and luma. Let's find where they are. Okay. That's really quite simple. So I need to remove the capacitor at C65, which is this one here. Apparently that now separates the chroma and luma so that the composite signal coming out of here, where it normally comes out of here, is now, I think, so chroma comes out of the positive side of where the capacitor was, and luma comes out where the composite was, and 5 volts is where it was anyway. There is one small thing here. I'm just going to trim this bit of tape along the edge here because it's in my way. Being very careful not to actually cut the circuit board. There we go. There's my cable. I didn't make it on camera because they're always a pain. I think I'm going to have to keep these as short as I can. Got to get this one right. I don't want any stray 5 volt wires touching anything else. I could tin it, but it's going to make it too thick. This one. There we go. Apparently all I have to do, plug this in with an S-video cable and it should just work. Now I've got to find an S-video cable. I can't find an S-video cable. Right. Pause and fade. It's the next day and a package arrived. A couple of packages arrived, but this is the important one. Actually, the other one's quite important as well, but we'll get to that in another video. So this is a Rhino Cables S-video cable. I don't know what that means, but it's a genuine product. And it's quite annoying that they put this label on without aligning it properly, and this bit's now sticky. So, sorry, but I'm taking that off because it's really annoying me. Oh, that's a very reluctant socket. It doesn't want to take the oh, that's gone in. Okay, just needed a bit of persuasion. Okay, here we go. Hey, it still looks really noisy. I don't know whether that could be like the power supply crossing over the S-video cable. No, it's not. Could be my LED lights. It could be my capture device. Let's try something with some colour. Okay, so that's a super noisy signal. That's no better than composite in my opinion, but there is something else to discuss that could be affecting it in a way that might be causing that problem. So when I took this cap out, which came out of here, C65, I thought I'll test it with my ESR meter, kindly donated by Ashley Heath. Thank you, Ashley. And it tested pretty much okay. In fact, really good. There's nothing wrong with that cap at all. It's a 22 microfarad, 16 volt. So I went around the other caps as well on the board and tested those. The one, its next door neighbour, I wouldn't expect to have a problem, is actually 3 ohms, which is still not too bad, and that's in circuit. But although this should be an accurate measurement according to the manual. 3.1, it's getting up a bit higher than I'd like. Let's move it over a little bit. Right, so this one is a 4.7 microfarad cap. So that's 11 ohms. Now that's a bit high. And for comparison, I've actually got some new 4.7 microfarad caps here. And that's under an ohm. So yeah, just under an ohm. So yeah, that's a bad cap. And there's another one here. This one has actually got some goop on the top of it. I don't think it's got anything to do with its reading, but just I found it curious. And this one's 5.7 and dropping. That's I think anything over 5 in my opinion, and this is not based on any kind of science, anything over 5 is something I need to change. Yeah, there's a few that are 3 and 4 around here. So I'm going to recap the board, and it's an issue 6A. The way I like to do these things is to print out a map which I get from retrolium.co.uk, and where you should buy your capacitors actually if you want to recap any spectrum. Then in my opinion, again, the best place to buy a capacitor kit is from Retrolium. It's just cheaper than buying them from any of the big retailers. They're going to charge you a load of postage for small ticket items like that. And Retrolium do really good quality caps, these same quality as these, and they are a really reasonable price. They're not earning a lot of money out of them, and you get really good service. Plus, the other thing you get from a Retrolium cap kit is everything you need for every issue of Spectrum, plus you'll get the composite mod kit caps with it, and transistors, or cap. You get a 100 microfarad cap to do the comp mod, and a couple of transistors for TR1 and TR2 to change those to boost the signal. It's just it's worth every penny. So anyway, the way I like to do this is to mark on the back of the board all of the places where the caps are, so that I can just do all of them at once. Now, I would recommend anyone else doing this, that you do them one at a time. Take a cap out, put it back in the same as it comes out, apart from on an issue 2 board where there's one that's marked on the silk screen. Actually, do it the same as the original cap, not the silk screen. But that's just one cap. Do them one at a time and test it between each of them in case you've messed something up. If you've done something like made a solder bridge or broken a trace or lifted a pad or something, you'll know where to look if you do them one at a time. But I've done this enough that I'm just very impatient. That's those two. There's one here. There. And I've just got one over here. Right, now I can just whiz around all of these with my desolder station and take them all out at once. And one's just trying to fall out already, I think. And the only problem I've got here is the legs are bent over. I've got the wrong glasses on as well. Right, so I'm just going to stand up these ones that have got bent over legs, because if you try and do this with the desoldered station nozzle, you will break the pad underneath, and it's quite easy to straighten these with a bevel tip. It's just a nice way to do it. It only takes a second and stops you breaking anything, so do it properly. Another good thing to do is to add some fresh solder if you are struggling to get the heat into the end of the pin, like that. Right, these are all, well, not all, mostly loose. Oh, I missed one. This one's just being a bit reluctant. I've just discovered why, unless I desoldered that just now, I think the green wire wasn't soldered. I'm going to have to check my footage from when I installed this, whether I soldered this in place. That could be where all the noise was coming from. Whoops. Where's that 4.7? Well, there's that grotty one. And where's the 4.7? That was an 4.7. Yep, 10 ohms. No good. I've had someone say that that meter is no good for checking capacitors, but well, it's without spending a huge amount of money, I'm not going to get anything better than that. That's going to give me a good indicator of a cap that's not performing as it should be and a cap that is performing as it should be. So I'm going to stick with it. I like it. And while we've got it, let's do this 4.7. Right, so I like to make sure that the values are on top when they're in the board, so that it's easy to see if you've made a mistake. And the next thing you should do when you recap a board is check all of the polarities are correct. And I'm going to check against this sheet here by touch. There's a notch on the positive side of all of the caps. Oh no, that's right. That's right. Oh, that's right. And that's right. And that's right. And that's right. Good. And last thing to check is for any bridges underneath with some magnification. And because I've got all of mine marked, it's quite easy for me to check where they are. So a little bit of solder splash next to that one. Let's get rid of that. Okay, I'm reasonably happy. That looks good. It's still going to work. That plug's freed up a little bit now. Right, here we go. Oh. Something's gone horribly wrong. All the voltages are there. What the hell happened there? There's still a lot of interference on that picture. I'm thinking it might be my capture. And I think the thing I need to do here is to plug it into my screen over here and check it that way. This is a bit of a shame. Oh yeah. Yeah, that's really good. There is still interference on there. It's a nice picture. I'm going to say it's a step up from composite. Yeah, it's not bad. Now, it's not HDMI or even RGB. Is there an RGB solution? Watch this space. Well, that is very weird. This won't boot. Oh, I've never seen that before. It's booting to a yellow screen, a yellow border, a black border. What on earth is going on here? I am going to give it another check underneath to make sure I haven't bridged anything, because that's the most likely thing to have happened here. Actually, I should check on top as well. Okay, I think I found the problem. I put a 22 microfarad in the reset circuit instead of a 1 microfarad. And that's C27. This is the reset cap. And that one, if you short it, that pulls reset low to, what is reset? Is active low, active low. So it pulls it low, pulls it to ground. And if I've put a 22 in there, that's what's happening. The reset is not working correctly. With the Steam Card Pro in there, it must have overridden that part of the reset circuit. So let's just pop that out and put the right value cap in there. So as well as checking polarity, you should also check you've put the right value caps in. Right, that can go back in the bin. And another good reason to put the values on the top and not the bottom. I don't know whether I did, I put all of the 1s in at once, and I put all of the 22s in at the same time, and the 100s in at the same time, and the 4.7 on it by itself. I'm going to have to look back through the footage to see. I might have just had a 22 in the wrong bin and grabbed a 22 by mistake. perfect now. There we go. Nice, perfect. Right, that's as far as I want to take this one. This is just a board that I'm going to have handy for putting in other things. When a case comes along, I can just drop this in, or if I've got a board that's just destroyed in a different case, I can put this inside. I've got no use for this one at the moment, but it's nice to have one with S-video connection on it. That will make things well, not necessarily easier, but will make things different for me and more interesting. And I'll be able to compare this to the other inputs if I can find a better way of capturing analog signals through one device. I need something that can capture composite and S-video, and component as well, I suppose. But there's not just very few machines that I need to use that with, so that I can compare them. And my retro scaler 2X cheap knockoff thing is poor. You get what you pay for. Don't buy cheap knockoff things. Anyway, thanks for watching. I hope you enjoyed that, and I'll see you in the next one. Cheerio. Like and subscribe. That's very aggressive, isn't it? Please like and subscribe. Yeah, I think I pulled it back there.